So 40C is where we are. This is the last part of lesson 40. And we're going to talk about inverse functions. How do we know when we have inverse functions? So here's how you know if you have inverse functions. Let's take function f and function g. If I were to take x and insert it into function f, whatever that might be, I would come out with f of x, right? And if I were to turn around and take that and insert it into function g, I would end up with g of f of x as a function, as a problem that I would then have to solve that function. Okay, and then I get whatever answer that is. We'll call that m, right? If I get m from that, then that's the answer. But then what if I take this same function and I reverse, or the same value that I started with, and put it into the opposite direction, right? I put it in g first, and I come out with g of x, and then I put it into the f function, and I come out with f of g of x, and I solve it, and I have the same value. When I end up with the same value on the end, then that is the definition of inverse functions. It means they are inverse functions to one another when you can solve them either way, putting f into g or g into f, and you get the same result. So let's see if we can determine if this next problem is an inverse function. So let's start here. We have 40.5, and we have f of x is 1/3 x minus 3, and g of x is 3x plus 9. So we're going to figure out if those are inverse functions or not. So let's look and see. All right, so first let's do this one. Let's do f of g of x first. So we're going to take g of x and substitute it in for the x in the f of x. So that is going to equal f of 3x plus 9. And we're going to put that in here. So it'd be 1/3 times 3x plus 9 minus 3. So that's going to be 1 times 3. This is going to be 3x over 3, so that's going to be x. And 1/3 of 9 is 3 minus 3, so the answer is x, because positive 3, negative 3 cancel each other out. So our resulting answer is x there. So let's do the opposite. Let's do g, f of x. So that would be equal to g with the f of x in it. So 1/3 x minus 3. So that would equal 3 with 1/3 x minus 3 plus 9, because we substituted this in for our x value in g. So when we do the calculation, we get 3x over 3, so that would be 1x, so just x. And 3 times negative 3 is negative 9, plus 9, these two cancel, so the result is x. So these are inverse functions to each other because we ended up with the same answer for both. So yes, these are, f and g are inverse functions. So let's try another problem. So let's do 40.6, and here are our functions. We have f of x is equal to 1 over x minus 3, and g of x is equal to 3x plus 1 over x. So we'll start with f of g of x. So that is going to equal f with the substitution of 3x plus 1 over x in for the x value. So that's going to be, let me see if I could wrap my head around this for just a second. Okay, that's going to be 1 over, parenthesis, 3x plus 1 over x minus 3. So I need to get a common denominator. So that is going to be 1 over, let's see, I'm going to give this an x. That's going to be 3x. So that's going to be 3x plus 1 minus 3x all over x. And this is my bigger division symbol because it's the one that's located next to the equal sign. That's the one we know we need to work with. So what I'm going to do is keep it, change it, flip it. And I'm going to say 1 over 1 times x over 3x plus 1 minus 3x. So then I get this. I mean, because 1 times this and 1 times this remains the same, right? So actually, let me back up a step. Before I do all of this, let me resolve this down here. So 3x plus 1 minus 3x, I should have seen this sooner. These two cancel each other out. So you just have 1 over x. So 1 times 1 over 1 times x over 1 just equals x. So that's our answer, is x. So let's try the other one. So we have g of f of x. So that means we're going to have g with a substitution value of 1 over x minus 3. Let me move this down because this is going to run into each other. There we go. So let me substitute that into my g value. So that is going to be 3 times 1 over x minus 3 plus 1 over 1 over x minus 3. All right, so let me resolve this numerator. So it's going to be 3 over x minus 3 and then to make this the same denominator, so 3 over x minus 3 plus 1, it's going to have to be x minus 3 over x minus 3 for this to be the value of 1 over 1 over x minus 3. Right? So what I see here is these are going to be combined. And when these are combined, I have a positive 3 and a negative 3. So those are going to cancel out. So this is going to end up being x over x minus 3 over 1 divided by x minus 3. So when I keep it, change it, flip it, I get x over x minus 3 times x minus 3 over 1. These cancel. My answer is x over 1, which equals x. So because this resulting value is the same as this resulting value, these are inverse operations or inverse functions, not operations, to one another. So that is how we would check to see if we have inverse functions. First, you start with one inside the other, and then you flip it, and you do the other one inside the first one. And that's all we have for lesson 40. So have fun with the practice problems, and I will see you in lesson 41 very soon.